Hello everyone, and today we'll be talking about typical ResNet architecture. My name is Aditya. Let's start. Starting with the introduction of ResNet architecture. ResNet stands for Residual Neural Network. It was introduced by Microsoft Research in 2015. ResNet is known for its ability to train very deep neural networks effectively. As you can see, the image showing is an example of a ResNet architecture. What is the motivation for a residual learning? Traditional deep neural networks suffer from the vanishing gradient problem. The vanishing gradient problem is that when you're trying to find the gradient descent, so suddenly the gradient will disappear. So this is called the vanishing gradient problem. Residual learning aims to address this issue by using shortcut connections. These shortcut connections allow the network to learn residual functions. As you can see, there is a diagram attached to it. You have the input nodes layer, the hidden nodes layer, and the output nodes layer. We have three input layers, four hidden layers, and two output layer too. Talking about the building blocks of ResNet, the basic building blocks of ResNet is the residual block. A residual block consists of two convolution layers with a shortcut connection. The output of the shortcut connection is added to the output of the second convolution layer. Stacking residual blocks. ResNet architecture typically stacks multiple residual blocks. Deeper resonance models have hundreds of layers. Stacking residual block allows the network to learn complex features. As you can see, we have a diagram of the same. Skip connections. Skip connections in ResNet allow the network to bypass one or more layers. Skip connection help with gradient flow and alleviate the vanishing gradient problem. Skip connection enable the training of very deep networks. As you can see, there is a diagram to show the skip connections. We have the convolution and pooling, we have the transpose, and then you can see the arrows depicting the skip connections. You have the encoder, you also have the decoder too. Residual learning concept. In residual learning, the network learns residual functions instead of directly learning the desired underlying mapping. The residual function is the difference between the input and output of a block. This approach simplifies the process and improves it. You can see we have an identity mapping that goes from X to the activation function after passing through the weight layers. The function is defined by f of x. Types of ResNet architecture. ResNet architecture comes in different depths such as ResNet 18, ResNet 50, ResNet 101, and ResNet 152. These are all the layers that is there between the input and the output. Deeper ResNet models tend to have better performance but require more computational resources. The choice of ResNet architecture depends on the specific task and dataset. Training ResNet models. Training ResNet models requires a large dataset and significant computational resources. Techniques such as data augmentation, batch normalization, and learning rate scheduling are commonly used. Pre-trained ResNet models are available for transfer learning on new datasets. Benefits of ResNet. ResNet architecture have been widely adopted in various vision tasks. ResNet models have achieved state-of-the-art performance on image classification benchmarks. The ResNet skip connection and residual learning concept have influenced the design of other neural network architectures. Talking about the application, image classification. ResNet models are widely used for image classification tasks such as identifying objects or scenes within images. They have achieved state-of-the-art performance on benchmark datasets like ImageNet. Object detection. ResNet serves as the backbone architecture for many object detection systems, such as Faster RCNN, YOLO, You Only Look Once, and SSD, Single Shot Multi-Box Detector. The deep features learned by the ResNet are crucial for accurately localizing and classifying objects within images. Transfer learning. Pre-trained ResNet models trained on large data sets that are commonly used, such as feature extractor for transfer learning. By fine-tuning these smaller domain-specific dataset, one can achieve good performance even with less data. Coming to the conclusion, ResNet architecture has revolutionized deep learning by enabling the training of very deep neural networks. The use of skip connections and residual learning has proven to be effective in improving gradient flow and learning performance. ResNet continues to be a popular choice for various computer vision tasks due to its performance and versatility. If you find this information contentful, please like and subscribe my video. Thank you.